Greetings and welcome once again to my new calculus channel. In a recent video, I berated a young lady and I'm really sorry about it. So I'm going to try and explain once again the same content with a view to helping her understand if I can. Now, so she asked these questions here. Now, she's obviously not expressing herself correctly, but I think she was sincere and I was being an asshole. So she says if pi is equal to 1 over x in the equation, then x is equal to 1 over pi, which can also represent diameter. I've no idea what she was talking there. So probably the problem there is she didn't really understand what I was saying. So let me try and explain again why algebra treats these exactly the same way. Okay, so let's pull up a paintbrush like that. Okay, so what we have here now is two equations, okay? We have 2x plus 3 is equal to 5, and 2 pi plus 3 is equal to 5. Now, this here wouldn't be true if we used the actual value of pi, wouldn't it? It wouldn't be true. So, for example, let's suppose that you try to solve pi here, you'd get exactly the same as you would for this x here, wouldn't you? For example, here x is equal to 1. But pi here is not obviously not equal to 1, but algebra would treat pi exactly the same way if we didn't know its value. So what I'm saying to you is that when you see a symbol like pi, algebra treats it exactly the same way as x. In other words, it only cares about the coefficient that appears before pi. So for example, if you have 2 pi plus a quarter pi, okay, that is the same as saying 2 and a quarter pi, okay, which is 9 pi quarters, okay. Does nothing. Algebra doesn't do anything with pi unless you physically put in an approximate value like 3.1 or 3.14, etc. Now, what does this all mean? Now, what does pi mean, by the way? So look, the value of the diameter, this line here, and let's make that green, and let's make this red. I wanted to get the length like that. Now, we can see here from this diagram here that the circumference is 6.85562 and the diameter is 2.1 something, okay? But if you try to measure this red line, the circumference, red circumference with the diameter, it doesn't matter what their lengths are, by the way. The lengths can be anything. Look, be anything you like. Anything. Could be close to 4, it could be 3, it doesn't matter what it is. If you try to measure it, algebra uses the fact that when algebra measures, so let's just clear this. When algebra measures a ratio, by the way, algebra measures a ratio. So this is the circumference, and this is the diameter. Okay. Now, what algebra does is algebra and geometry try this, but algebra is a little different to geometry. Geometry would simply take that value and go, 1, 2, 3, and a little bit. And this little bit here would just simply be this little bit here with a compass, right? Physical measure is 100% correct. No problem. Okay? Algebra, however, goes a step further than geometry. It says we are going to measure in terms of the diameter, which is this, in terms of the diameter, right? And or equal parts of the diameter, right? They're not. This doesn't look equal, but these must be equal parts. So algebra says, okay, I can get that diameter in 1, 2, 3. How am I going to describe this part in algebra? Big question. How am I going to do that? Well, your stupid teachers don't tell you these things because they don't understand the concept of number. Even your lecturers don't understand this. Algebra uses an abstract unit. And what is the abstract unit in this case? It's the diameter, okay? So it takes this unit, okay, and equal parts of it. Now, if you try, let's say, 10 equal parts, you're only going to get a value of 3.1. If you divide this unit into 100 equal parts, you're going to get 3.14. There's always going to be a little bit left over here. Don't worry about the proof of that. It is true. If you take 1,000, it's going to be 3.141. If you take 10,000, it's going to be 3.1415. If you take 100,000, it's going to be that. Okay, so you cannot measure this ratio. That's what happens here in algebra. What algebra does is it uses an abstract unit, this green diameter, in an attempt to enumerate how many times the diameter fits into the circumference. Now remember, geometry doesn't care about number. It says, hey, I'm going to take that diameter, and here's a diameter, and it's 1, 2, 3. Okay, 1, 2, 3, like that. And in algebra counts. It uses a unit. It assumes that's 1, that is 2, and that is 3. And then there's a little bit left over here. How do we describe it in algebra? Well, in geometry, we just simply take that little bit with a compass, take that little bit off like that, okay, from the diameter. In other words, if we went 1, 2, 3, okay, that's not exactly 3. This little bit here, we just take off the diameter, all right? So that's in geometry. But algebra, you have to explain this little bit here. Okay, how do you explain in algebra? Using equal parts of the unit. That's why I tell you what the definition of measure is in geometry and algebra, and it's very important for you to understand this. You cannot be a real mathematician without understanding this. Yes, I know that means none of your lecturers are mathematicians. They're not even mathematicians anuses. Now, to learn more of what I'm telling you here is you go to academia and you download this book here, Learning the Correct Way. By the way, it's gone higher than 4%. It's probably closer to 2.5% or maybe even 1% by now. But this is a free ebook with a watermark. It explains all these concepts to you. So it's important for you to download that book. If you want it without the watermark, you go to Amazon and you support me by buying the book without a watermark. Okay. It's this book here. It's The Importance of Learning the Right Way. It's $10 or €10. But you can get it free because it's so important. I've made it available free. Then you can also learn what the arithmetic operations means. You know, arithmetic operations are realized entirely without number. Okay, number comes much, much later. Even measure happens long before number. Those sniveling, driveling morons who are your mainstream professors and teachers do not understand these things. Okay, they have no idea what's going on. That's why they produce a bunch of clowns every year. Okay, every year, more idiots roll off the production line. What I'm telling you is that it doesn't matter what diameter you use. Okay, and the length of this doesn't, you can't say let this be 1. There is no 1 unit. This acts as a unit. The whole thing is a unit. Doesn't matter whether you do that or that or that or that. It is a unit, okay? Because it's used to measure the circumference. So the actual size of the unit is irrelevant. And guess what? The actual size of the circumference is irrelevant. Look there, you've got a circumference of 8.59, or approximately 8. Let's see if we can make that. Approximately 8 doesn't mean anything. Okay. The circumference and diameter can be any length you like. The important part is that if you try to measure the circumference with a diameter, you get approximately this value. So if you take if you take 10 equal parts, it'll just be 3.1. If you take 100, this. If you take 1,000, and so on, and it becomes more and more accurate. But it's never the value. It's never the exact measure of this ratio. And what is that ratio? It's the ratio of the circumference to the diameter. Okay, 3 times goes in there, and a little bit, 3 and a little bit. 1, 2, 3, and a little bit. This little bit here. I hope that clears up things for you. Please go to my academia site, this one here, and study these articles. I'll also give you the realization and development of number in one complete page. This has never been done before. Also, never been done before is how the arithmetic is realized without numbers. Okay. Nothing like this has ever been published, not by Descartes, not by anyone. I'm the first to publish this realization. Yes, I am a genius. Sorry, a genius has to know he's a genius. Otherwise, he's not a genius, right? I don't need you to tell me I'm a genius. I don't need anybody to tell me you need to be humble. Humility has got nothing to do with mathematics. Okay. Mathematics is based on fact. You either are using facts or you're using drivel like George Cantor or those 40 Bourbaki idiots who smashed the beautiful Greek foundations and replaced them with the bullshit of ZFC and the 9 axioms. Okay. So if you're not already a subscriber to my channel, become a subscriber. Click like, yes, click like on my channel, because if you don't, my enemies, the stupid people who are mainstream academics, will constantly vote these videos down. As a result, you will suffer, your children and your great-grandchildren. And because I have been treated the way I have been, there is much I haven't revealed. Okay. And I'm not going to unless I'm recognized and given a substantial financial reward. That's right. Over €1 million at least. That's it. Otherwise, you don't get to see anything new. I'm John Gabriel, and this is New Calculus Channel. Till next time, goodbye.